Hello, welcome to the Friday, December 4th, 2020 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich, and today, I'm in Jacksonville, Florida, but actually teaching at SANS Frankfurt. And with that, let's take a look at what we have in diaries. Today, we have another traffic analysis quiz by Brad. So if you are into analyzing PCAPs, and this week I'm actually teaching the intrusion detection class, so fits really well. You can take a look at what Brad has put together here for you as a challenge. And you don't just get the PCAPs, you also get links to tutorials he has put together in order to teach you about Wireshark and help you analyze this particular packet capture. And an item I probably should have covered yesterday is an article by Google Project Zero's researcher Ian Beer. He discovered back in, actually sort of a year ago, November 2019, a vulnerability in iOS that Apple later fixed with iOS 13.3.1 and macOS 10.15.3 at the end of January of this year. What makes this vulnerability so notable is that it may be exploited wirelessly. It does not require any user interaction and essentially leads to a full system compromise. The bug was a part of Apple's wireless direct link protocol, or AWDL. This is the protocol that iOS and macOS devices use, for example, for AirDrop. While fundamentally it's basically 802.11, it is sort of Apple's own take on it to set up these ad hoc peer-to-peer networks. And an attacker in this case would have to be able to essentially hit a particular vulnerable device with a specially crafted AWL packet. Now, what's really neat about this entire story is, first of all, that Ian wrote this amazingly detailed blog post about it, but also that he went way beyond actually just finding the flaw. We do have a lot of sort of wireless vulnerabilities like this, where researchers essentially find the flaw, they are able to cause some software, maybe a system crash, but that's where they stop. And if you're reading that blog post, you kind of understand why, because there's an awful lot of work involved in taking it to the next step and actually writing a usable exploit for this. And that's exactly what Ian did. Now, it took him, I believe, a full 6 months to get to this point, but lots of details in this blog post about this protocol and about how he went about finding this flaw and then how it was exploited. Now, first of all, of course, make sure your version of iOS and macOS is up to date. But then again, the patch for this was released back in January. There are a couple additional flaws that Ian found that were patched in July, I believe. But still, keep your systems up to date is probably your best defense at this point. And, wireless interfaces, yes, people always tell you should turn them off in environments that you don't trust and such. But then again, when do you ever trust your environment? And of course, these wireless interfaces are integral to the functioning of these devices. Now, this was a nice story sort of about some proprietary software. And of course, a lot of the work that Ian had to do was reverse analysis of this proprietary software. One would think that, maybe things look better for open source software. Interesting report from GitHub about this. GitHub did publish its annual State of the Octaverse report, and one large chapter of this report is dealing with security. And of course, one focus of GitHub in recent years has been to provide more tools and really more attention to security. Interestingly, it takes about 4 years for a vulnerability to be disclosed. And once disclosed, and that's, I think, kind of a good number, it takes just over 4 weeks to actually release an update and patch the vulnerability. Most of the vulnerabilities identified are honest mistakes, according to GitHub. Now, that is based on a sample that they pulled from the alerts. However, I think that number is still a little bit big. 17% of the advisories were related to specific malicious activity. So this is essentially code that a developer specifically added, like backdoors and such. Good side of this, these packages were only used in about 0.2% of these triggered alerts. So in short, yes, there are quite a few sort of backdoors and such in open source code, but typically not in very popular used open source projects. And overall, GitHub here feels that its efforts to help developers create more secure codes and find vulnerabilities is working, and that developers overall appear to be responsive. Well, it's Friday again, so today I have yet another sans.edu student with me. Christopher, could you introduce yourself, please?
Hi, my name is Christopher Hurlis. I'm a systems engineer at Northwestern University on the Cutter campus.
So your paper was about the critical controls and, well, actually a little bit more practical. The critical controls are always a great idea, but how to actually implement it with tools like OS Query and such. Can you tell us a little bit about that?
I really wanted to see if I could use OS Query to dig into the CIS benchmarks on a system and report the CIS benchmark status at scale. Because just setting the benchmark isn't enough. You really need to audit it. So I wanted to find a way that I could continuously monitor the status of my endpoints and make sure that they were compliant with my CIS benchmark requirements.
Yeah, so these CIS benchmarks, I always like them because they're somewhat prescriptive kind of in what to do, and always lots of support there also available. But a lot of companies struggle with actually implementing them and, like you mentioned, sort of monitoring compliance with these benchmarks. So how does OS Query help with that?
Well, I can actually agree with that statement a lot because I think one of the issues I found with the critical controls was that the means of auditing the different controls is sort of across the landscape of the operating system, and you'll have one program that you might use to monitor password policies, and then a different program to monitor firewall policies. But there's no real centralized way to do that, and even OS Query failed to do that out of the box in a lot of cases. So what I ended up doing was actually doing just a little bit of Python programming, and using Python to do some operating system calls to get the data that I wanted into a plist file, and then I just had OS Query read the plist file, which would then report back into my Elastic Stack and give me the data that I was looking for. And by the way, all of the shim, the OS Query to CIS shim that I wrote is on my GitHub page.
Okay, so people can actually go there and basically save themselves the work to recreate some of that.
I mean, I got to put a disclaimer on there. I mean, your mileage may vary, but definitely the proof of concept is there, and I think you'll pretty quickly see my means and methodologies, and be able to sort of port that into your own requirements for whatever controls you personally happen to be monitoring for your organization.
Now, OS Query, when most people get started with it, the appealing part, of course, you have this SQL-like kind of query language to query parameters across your network from systems, but it's usually more used interactively. How do you sort of get that continuous part going, where you continuously check if your systems are in compliance with certain standards?
Well, for me, what I did in this case is, I feed the logs through to a seam. In this case, it's Elastic Stack. I've also used Splunk for this, which is very effective. For each of the benchmarks, I'll create maybe a dashboard um, so that I can quickly look at the benchmarks that I'm monitoring. And then if the benchmark falls out of what I intended it to be or changes, then I will create. In this case, I created Elast alerts that forwarded that log onto the Hive. And then from the Hive, I would actually go so far as to create step-by-step instructions for investigation and remediation. And this part I really liked because having that step-by-step process, I think it allows us to bring any IT staff member into the fold of security. And I've always felt that security is an everyone problem, not a security department problem. So I like the idea of giving everyone exposure to the means and processes by which investigations happen, because it is some pretty advanced stuff, and it really helps with the learning part of security by just following through the process.
Now, the use of the Hive Fear is interesting, I think. I've used it for malware analysis and such to automate some of this. But you're kind of using it as an orchestration platform to automatically respond to systems that are essentially out of spec, but not necessarily compromised.
Yeah, that's right. I mean, because you can do both at the same time, right? When you see that it's out of spec, that could be an indicator of compromise. And there's going to be several tasks that you're going to want to complete to make sure that it is or is whether or not it is, or to understand whether it is or is not an indicator of compromise. And you don't need necessarily, your top tier security analyst to do that. That could be a very quick, 3-step process from a support staff who just sees, that all of a sudden the firewall on a machine is off, and that could be because a faculty member turned it off because they didn't understand what they were doing, or it could be because a piece of malware turned it off, so it could do something else. And I think you can build that all into the Hive, the way it's built, especially as you start to assign tasks to different people and maybe different levels within your organization.
So how do you respond then if you see the firewall is turned off? Do you turn it on automatically, or do you just notify users that, hey, that system is out of compliance, and then respond manually?
Well, I mean, the cool thing is you could decide how to do this however you want. But what I might do first is look across the Hive and see if any other events happened, such as an application or a new application got installed on that machine. And you can do that from if there was an alert on it, or you could go back to OS Query. In this case, you would use the Collide Fleet service to query machines directly to find out more about what happened. So maybe in the Hive, you say, okay, if the firewall gets turned off, go to Collide and run this SQL statement to see if any new applications are installed. You could also look within the Hive and see if any other tickets were launched or any other Elast alerts were made. And you could even divide those tasks amongst multiple people who all, investigate independently on the same alert.
Yeah. So basically, with the alert, the analyst then gets some context in what happened to the system to make it easier, faster to come up with the conclusion whether or not it's malicious or innocent behavior from some user that just installed some new software and it didn't work, so they turned off the firewall.
Exactly. And, ultimately, your final step will be how to bring that machine back to the desired state, which is also part of the CIS controls, right? Because CIS control will show you both audit and remediation. So everything that you put between audit and remediation is up to you.
Excellent. So OSClear, of course, a tool that is known to scale very well, being created by Facebook, I believe. Your overall system, have you deployed it in a network, or have you really just done it sort of as a research project so far?
I am using it. Right now, we use it in our lab machines here in Northwestern. I do not use it with Elasticstack or the Hive just yet, and I use it with Splunk, and it's very effective. I build the queries one by one, and then I build the dashboards to go along with them, and then we decide what we want to alert on. And I find it remarkably effective and easy to work with. And I very much hope to expand it even further as the success within our lab environments is proven.
Excellent. So you're almost done with the Sans.edu program now, or anything left for you?
Well, I'm coming up on the Python course here.
Okay.
I'll be doing a live online. This will be my first live online, so I'm pretty excited for that. And then I also have the core competency test, which, it's funny, you guys gave me 2 scenarios as a practice exam, and when they were over, I was very disappointed because I wanted to play more.
So an exam that's actually fun to take.
Yeah, it was fun problems to solve. Yeah, I'm looking forward to that.
Excellent. Thanks for joining me here today. And the link to the paper with all the details, and the paper also has a link to the GitHub repository, will be in the show notes. Thanks for joining me here, Christopher. And thanks everybody else for listening. Talk to you again on Monday.